In this video, we are interfacing an keythley multimeter 2700 multimeter bar data acquisition system using a LabVIEW. Here I connected the keythley instrument to system through an RS-232 USB interface. Okay. So now we are connecting this instrument. So now you can see that port is modified. So this is a USB serial CH340 COM6. Now I am creating a new project. So I am selecting a blank project. And I am creating a new VI. Okay. So this is our front panel and this is our block diagram. Okay. So here first we want to initialize our instrument. For that I am finding out the driver. So in instrument IO you can find out the instrument drivers, and here we have keythley instrument drivers. Okay. So first I want to initialize our keythley 2700. Okay. So first I am taking this initialize VI. Now once it is initialized, we have to configure this particular instrument. So this instrument can measure in different things like DC voltage, AC voltage and all. So I want to configure the measurement. So once measurement is configured, we can perform the data conversion. Okay, so I want to read the data and I want to display this data in a block diagram. Okay, so for that I am adding a graph, one waveform chart. Okay, so now we want to do the connections. So first you can see this is the visa resource name out. So we can connect all these lines. And and error out. Okay, now this is I already told you, this is our initialization. So what are the information we have to give to initialize the instrument is, one is visa resource name, another one is ID query, so that is serial configuration and error. So first we have to give the visa resource name. Okay, so earlier I told you our visa resource name is COM6. Okay, so first we have to add a constant. So from here we can select our visa resource name, that is COM6. Next, these things are not necessary. Okay, so I am leaving. So now another thing is configuration. Okay, so in the configuration case we can do different kind of measurements. So for DC voltage measurement, the function is a constant, that is 0. Okay, so this is already configured for DC voltage measurement, and this is the resolution, and this is auto range enabling option. Okay, so anyway right now we are going to try with this one DC voltage. So without any modification, the default is DC voltage, and this is measurement data output, so that we are feeding to our waveform chart. So our work is over. Now we can run our program. Or you can check whether our program is running properly or not. Okay, so see, it is okay here, it is okay here, and values received here, and it is output given to waveform chart. So that values pop up here. Okay, you can see here. Okay, so if you want to do the measurement continuously, then you can do one thing, that you can add a while loop. Okay, so I'm giving this while loop for data measurement and waveform chart. Okay, and we have to create a loop condition, that I'm creating a controller. Okay, so one stop button is pop up here. So now we are going to call this data. Okay, I'm just stopping this highlight option. Okay, now we can see this is calculating the DC voltage. Now you can see this signal is collected to our LabVIEW program. Okay. So this is the basic LabVIEW program for collecting the data from keythley 2700. Now we can explore more options. So this keythley 2700 can be operated as it have multiple functions. So it can act as a DC voltage multimeter. So here you can see there is multiple options are there. We can use it as a DC voltage meter, is a DC current meter, AC current meter, resistance measurement system. Okay, so these are the basic. So these are the various options we can use. So if you want to measure AC voltage, you have to choose this AC voltage. So this constant will be changed to 1. And if you want to measure frequency, you have to change to frequency. So the constant is 7. Okay. Another thing is you can choose the resolution. So we can select different values from 3.5 to 6.5, and here you can use this auto range mode or manual mode. So you can choose, you can toggle between manual mode and auto mode, and also you can specify the manual range here. Like 0 volt, 100 volt, 700 volt. Okay. So now it work is in a auto mode because this condition is true. Okay. So if toggle to off, then it will be enabled the manual range. And here also you can choose different methods, that is multiple buffered enter buffer method, buffer subset, or single value. And another thing is we can save this data to one Excel file. So for that we have to go to Express VA and select this output. So here you can see write measurement data to file. So this is the option to set up, configure the write to measurement list file. So you can specify the name and you can choose these various options. Okay, so I am choosing TDMS, so this is very easy to open in Excel format and it give more information about the instrument parameters and all. Okay, and I am choosing only one column only, and here I want to use next available file name. So and I'm clicking OK. So that setup is already ready, and I have to wire this one to here. Signal. So now if we run this program, so it will cut this signal. So now it is working in the AC mode because we chosen to AC, and I am stopping. So there will be a data saved to this file name. Okay, that is in E. We have to see where it is saved, that is test. Okay, so this is the thing. So the problem is it created multiple files, so we can do one thing. We can choose. Okay, so we need to modify that one to one header only. Okay. Okay. So now again running the program. So it asks to where we have to save this file. So this is the location where we have to save the data. Okay, now we are stopping this program. Now we can see this saved to AC voltage and the data is collected here. Okay. So this way you can write the data to an Excel file. Okay.